Hey guys, today we're going to wrap up everything we've been talking about so far with Unit 3, and it's going to end talking about modeling. Modeling is kind of another way to say we're going to be doing some word problems. So we're going to start with this problem where we have this time that's passed and then the concentration of some medicine in a patient's bloodstream after the certain amount of time. And so we want to find a cubic model to represent this data. So whenever we say cubic model, if you guys remember back in Unit 2, we were doing exponential regression. In this case, instead of doing exponential, we're essentially going to be finding a cubic regression equation that models this data. And so I'm going to show you how to do it on a calculator because that's going to be like the easiest way to do it, I think. And then I'll also go through one of them on either the quadratic or the cubic regression calculator that I linked on the weekly assignment calendar. In case you don't have a calculator at home, you'll at least be able to get the equations that way. So, but first I'm going to go through and I just want to find a cubic regression equation that models this data. So I'm going to pull up my calculator. And I can see all of the data if I put it here. So it's going to be the same steps for exponential regression, except you're going to be finding cubic. So we're going to still go to stat edit, and we're going to enter our numbers in our list. So for L1, we have 0.5, 1, 1.5, 2, 2.5, and 3. And so that fills out the L1 list, and now I'm going to go over to L2, and I'm going to type in 0.16, 0.19, 0.2, 0.9 again, 0.18, 0.17. And that fills out my L2 list. So I have all of my data entered. So now I'm going to hit Stat again and go over to Calc. And this time I want to, instead of scrolling down and choosing EXP-Reg, I want cubic regression. So that is down here on number 6. So I'm going to select that. And if you remember when we were doing exponential regression, we always stored our regression equation in y1. So we're going to go to vars and then over to yvars, press enter on function, and enter on y1, and then we're going to calculate it. And so our cubic regression equation that we're going to get is 0.0118 x cubed minus 0.082 x squared plus 0.164x minus 0.0967, essentially. So what I'm going to do is I'm going to pause and get a screenshot of what that looks like so that I can put it in our notes so that we can refer back to it. Okay, so now I want to actually write out my equation. So you see in here it has ax cubed plus bx squared plus cx plus d. So I just need to fill in each of these letters in my equation, which is what I kind of did verbally a second ago. So I would have y equals 0.119 0.0119, and then that is x cubed, and then minus 0.0822 x squared plus 0.1645 x, and then plus 0.0967. And that would be my regression equation. So that's what you're going to use for the equation. Then it asks, when was the concentration? 0.1825 milligrams. So what we actually can do for that is graph it and then find the intersections where y equals 0.1825. So I'm going to go ahead and graph our equation really quick. Okay, so I graphed our equation on Desmos, and then I zoomed in a little bit because it was a little bit hard to see my intersections with y equals 0.1825, but I can still find them, so I'm going to go through and click on all of my intersections, and for when is the dosage 0.1825, it's going to be at all of these x values. So 0.813, 2.4, and 3.6. So I'm going to copy this into our notes as well. So then to answer our second question, for when was the concentration 0.1825, it's when x equals 0.813 or 2.401 or 3.693 hours. So this would be our second answer, and then this would be the answer for our cubic model. So then I also want to go through just how to find that equation using the online calculator that I posted. So this one asked for cubic regression, so I'm going to click here to pull up my cubic regression calculator. And it tells me this is a little bit different. Instead of giving me columns, it tells me to enter my x values and my y values. So for x values, you're going to enter all of the values that are in the first row. So that was 0.5, and then we separate them with commas. And then 1, 1.5, comma, 2, 2.5, and 3. And then for the y values, they were 0.16, comma, 0.19, comma, 0.2, comma, 0.19 again, comma, 0.18, comma, and 0.17. And then you're just going to hit calculate, and it brings up the regression equation down here for you. And it's the same one that we got in our calculator. So that's how you would do it if you're using the online calculator instead of a TI-84. So now on this next one, it's talking about the number of students who are sick with the flu after winter break, and it wants us to find a quadratic model to fit the data. So this time I'm still going to come on my calculator, and I'm going to just clear out the cubic one we had, and I'm going to go back to stat edit. To get my previous list cleared out, I'm going to scroll up to hover my cursor over L1 and L2 and hit clear and then enter. And I'll do the same thing for L1, and then I want to enter this data that's given. So I have 0, 5, 10, 15, 20, 25, and 30 days is what's listed. And I want to go over to L2 and enter the number of people who are sick. So we have 3, 6, 14, 23, 23 again, 21, and 9. And now I want to calculate a quadratic regression model. So I'm going to go to Stat, over to Calc. This time I want Quad Reg, number 5. And I'm going to press Enter on that. I'm still going to store my regression equation in Y1, so I'll go to Vars, over to Y-Vars, and press Enter on Function and Enter on Y1. And then I can calculate it. And so my quadratic regression equation it gives me is going to be negative 0.068x squared plus 2.45x minus 0.476. And then that's it. So let me copy this over so that we can write our regression equation. Okay, so we're going to write it out the same way we did the last one. So we have y equals a is negative 0.0681, that's x squared, plus 2.45x, and then minus 0.4762. And that would be my regression model or regression equation that matches this data. And then I want to estimate the number of students sick on day 18. So that just means that x equals 18. So what I can do is go back in here and plug in 18 for each of these x's. So I would have negative 0.0681 times 18 squared plus 2.45 times 18 minus 0.4762. And this is going to give me an estimate of the number of students sick on the 18th day. So I'm going to type that in my calculator too. So when I calculate that, I got 21.5594, and I'm just gonna round that up to 22 students who are sick on day 18. So we're gonna say 22 students.